Analyzing current methodologies. Agile software development methods and free and open source development have been two embracing movements in the software industry for more than a decade. However, little is known about the composition of both, while today a variety of studies provide us with key characteristics of each. The developers who gathered to develop the Agile Manifesto were not just theorists, they were dedicated practitioners who went on to create development methods based on Agile principles. These methodologies include extreme programming. XP has received the lion's share of interest among the Agile methods. XP drew attention because it converged with many of the practices that developers were discovering in a real project, and because its initial successors, including the well-known Chrysler Comprehensive Compensation Project, coincided with the Internet movement and the need for an approach geared to speed to value and exploratory innovative projects. XP is focused on software development and is not presented as a project methodology. XP doesn't scale to teams larger than 10 or so and is not well suited to virtual or dispersed teams. XP is presented as a series of principles that Agile developers should follow. These elements include the following: the planning game, a recurrent workshop in which developers and customers interact in order to create and refine the stories that describe their project. Small releases with high-value elements. Every release should be as small as possible, containing the most valuable business requirements. Metaphor. The overall idea of a project, the broad goal as a narrative or story to keep the technical jargon at a minimum and build a collaborative vision between developers and customers. Simplicity. The idea of simplicity is central to XP. The delivered product itself should be simple, delivering the needed features in the simplest manner without trying to speculate how the bells and whistles that might be useful sometime in the future. The use of the methodology and technique should be simple too. XP developers avoid documentation other than stories and test cases unless there's a convincing demonstration of their value to the customer. XP practitioners strive for elegance and simplicity in their actual coding practices, which leads us to refactoring. Refactoring is the optimization of the internal code in the architecture. It's a key element of XP. It's also a response to one of the hazards of iterative design, the danger that the separate iterations will be poorly integrated and internally incompatible. Dynamic System Development Model, DSDM. Developed in 1994, DSDM is the oldest of the recognized Agile frameworks. DSDM was developed as a structured approach to rapid application development, a popular methodology of the early 1990s. It incorporated many of the fundamental concepts of iteration, incremental delivery, and customer collaboration that typify the Agile methods that have become popular since the Agile Manifesto was published. Crystal methods. Alistair Cockburn, the developer of a collection of methodologies known as crystal methods, says that he developed crystal methods to get rid of this aberration called software engineering. Engineering, he says, gives us questions like, is our model accurate? Instead of the more interesting questions such as, is our product meeting the customer's needs? And do we have our goals aligned as a team? In line with Cockburn's emphasis on these questions, crystal methods is primarily focused on communicating with special focus on interaction, community, people, and skills. Lean development. In 1989, Professor James Womack and consultant Daniel Jones published Lean Thinking, a survey of the lean manufacturing techniques that helped create the Japanese miracle of the late 1980s and the early 1990s. They chronicled the ideas of lean manufacturing with their focus on eliminating waste, creating a smooth flow of work on the factory floor, and expecting workers to contribute a high skill levels and an ownership mentality. These concepts help Toyota, the exemplar of these techniques, vault over the traditional giants of the automotive industry. Like Scrum, LD is more of a project management environment than simply a software development. It consists of three distinct phases: startup, steady state, and transition renewal. Rather than a daily Scrum, it recommends a time-boxed whirlpool. Like all Agile methods, it includes analysis, design, test, and build activities in the iteration. Constructing improvements to the model. Part of getting to Agile is identifying the sweet spots of effective software development and moving the project as close as possible to those sweet spots. A team that can arrange to land on any of those sweet spots gets to take advantage of some extra efficient mechanism. Some anecdotal evidence demonstrates success of the extreme programming practice in a portion of the software industry. It has been argued that pair programming as a part of the extreme programming process yields higher quality software products in less time. On the other hand, these principles are sometimes questioned with respect to the resource allocation and management issues. Software process improvement, or SPI, aims at providing a means for improving the capabilities of software development teams and organizations. SPI methods have been intensively studied and developed since the early 1980s. Lately, the traditional methodologies have been challenged by Agile software development approach, such as extreme programming. The underlying principles of Agile processes propose that at regular intervals, a team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. However, there is still not enough guidance or empirical evidence available on how to execute these improvements rapidly and effectively in the Agile-specific manner, while still taking into consideration the aspects found in fundamental treating of SPI. Recommended ways to control the Agile process. When one team adopted extreme programming and Scrum, there were a number of challenges. Integrating an Agile team in a traditional organization created friction. And in spite of ability to deliver rapid increments of usable functionality, Agile software development processes are frequently characterized as uncontrollable, unrepeatable, and incapable of optimization. Christensen shows us how to manage this by using a straightforward three-step procedure that has been successfully applied in the process industry for more than 50 years. Step 1, control the process. Agile methods focus on incremental delivery and feedback on product value versus user needs following each increment. Quick action can then be taken on the next increment to bring the product closer to meeting the user needs, even if these have changed from the previous increment. Step 2. Once a process is under control, as much of the process as possible should be automated in order to ensure consistent process performance and improved product quality. Quality tools such as CodePro, Analytics from Google, Support process automation by providing code audit tools that detect violations of good programming practices and provide auto-fix capabilities where possible. Step 3, optimizing the process. In preparation for the process optimization, there are 2 key questions you should ask about any automated quality tool. Can the tool export the results of analysis? And can the testing in a format be suitable for importing in statistical databases? Once process measurements are acquired and retained in statistical database, they can be applied using well-known statistical methods. Conclusions. Agile development is a great approach to development. It's not a panacea. It won't work miracles. Software development requires professional effort, and agile development is no exception. It must be applied thoroughly, carefully, and with attention to detail and nuance. As external validation efforts, BMC's DSM development team was given the 2006 Innovator Award by Application Development Trends. Using agile methodologies, BMC took the project that was less than a year away, with teams split across 11 time zones, 3 countries, and successfully combined the company's solutions into a single platform in just 10 months. In another example, the author had a unique opportunity to experience and analyze the adoption of agile practices on 2 projects at a major car company, which sharing many similarities, including staff, professed commitment to agile process, architecture, and programming environment, experienced 2 drastically different outcomes. The first becoming bogged down and eventually went into production late over budget and with fewer features than expected, and was only reluctantly embraced by its user community. The second one was ready for its first production milestone after only 9 weeks, was enthusiastically embraced by the users, and went on to become unqualified success for a model for the other software development projects.